Bienvenidos nuevamente al seminario y a la Red Internacional de Sistemas Sociales y Complejidad. El día de hoy iniciamos celebraciones con la presencia de muy reconocidos especialistas de México, América Latina, en la teoría de sistemas sociales, lo que nos llena de orgullo y satisfacción. En unos instantes damos comienzo al conversatorio El futuro abierto en una época algorítmica, una discusión con Elena Espósito, la cual es profesora de la Universidad de Bielefeld, Alemania, y de la Universidad de Bolonia, Italia, así como los profesores Aldo Mascareño, de la Universidad Adolfo Ibáñez de Chile, Rosario Rogel, de la Universidad Autónoma del Estado de México, Gastón Becerra, de la Universidad de Flores y la Universidad de Buenos Aires, Argentina, Jorge Galindo, de la Universidad Autónoma Metropolitana, sede Coajimalpa, en México, José Javier Blanco Rivero, de la Universidad Central de Venezuela, y por supuesto, el profesor Dominique Hoffman, de la Universidad de Bielefeld, quien es el coordinador del conversatorio y a quien con mucho gusto le cedo la palabra. Dominique.
Muchas gracias y bienvenidos a todos, todas. Con eso ya voy a cambiar al inglés, because the language today for the discussion will be English. We will begin the discussion right after some very few introductory remarks I will have about the way the format is planned today, and after a short introduction of our guest, Elena Espósito. So the idea is to take the title we gave this event very seriously and really have a discussion with Elena Espósito about the topic of algorithms and how they change the way in which we perceive the future. We are, well, at the moment, if I count correctly, 8 people online. So yeah, I will moderate and try to keep the discussion more or less ordered. Apart from that, we're gonna have a really free conversation between colleagues. That's the idea. And with that, I introduce the guest today. Elena Espósito is a professor at the Universities of Bologna and Bielefeld. The latter since she held the Niklas Luhmann Gast Professorship in 2015, from which occasion I actually do remember her inaugural lecture. When I was thinking about how to introduce her today, I remembered the introduction she was given then, and I remembered that it was done by reference to a quote by Hans Magnus Enzensberger, passed away recently, and who apparently said about you that you are a philosopher who, just out of modesty, calls herself a sociologist. And I bring this up not to add to sociology's inferiority complex or to steal my introduction, but rather to object to it. And you can object to my objection, but I would say that actually Elena's work is the best proof for the fact that sociology does not have to fall short of philosophy in terms of complexity of argumentation, and that often philosophical problems are only so interesting as the solutions that society and social systems find for them. And in a certain way, this was already the topic of Elena's PhD, which she did under Niklas Luhmann here in Bielefeld, and which I think could be considered a sociologization of modal logic. And it is, I think, fair to say that this also, the ways in which social world treats modality has remained a central topic, maybe the central topic of her work from then on, with a special focus on the temporal dimension. which is to say the ways in which society harvests the past and the openness of and the uncertainty of the future for present action. This is what connects the topics of fashion, of social memory, of financial markets, of statistical thinking, about which Elena has written extensively. And I think it also very much refers to the topic about which we are going to discuss today, which is the topic of algorithms. I also remember that the title, internet confirmed it, that the title of the inaugural lecture I just mentioned was Artificial Communication, which of course is also the title of the book, which will be the base for the discussion. And with that, I hand over to you, Elena.
Thanks so much, Tim and Dominic, and thank the organizer for having me here. I'm really, really happy to have the opportunity to talk with you about my work, about the book, but also the topic's perfect because we also, Dominic knows it, in Bielefeld, we work on system theory, which is the background of everything what we are doing, but we have, I say we, because Dominic also involved into that, we have now, we are working since a couple of years in a slightly different way from what I've been doing for a long time, because we have this grant by the European Research Council with the title The Future of Prediction that combines this system theoretical background with empirical research in different fields. The full title is The Future of Prediction, Social Consequences of Algorithmic Forecast in Insurance, Medicine, and Policing. And I would be delighted to talk about it, but I want maybe in the discussion, but not now, because as Dominic told me, the idea today is, which for me is really inviting, really nice, is to talk about, the background of this research, which is the book on artificial communication, which is actually the background of the project. But I said before that I want to use the opportunity. Dominic told me, you know the book more or less, which is a big privilege. So I want to say something about the book, because I want to talk just for a couple of minutes to introduce the discussion. But I thought that I can use this few minutes to say something which is not in the book. And for me, it's very important. And as I said before, I'm really happy to have the opportunity to say it now, because it rarely happens. To explain in which way this book is really a book about system theory. It's a system theoretical book. Even if Luhmann is mentioned, you notice that certain knowing him is mentioned not so many times at the beginning, and sometimes here and there. And it could seem, or it's also, it is not by chance. I think it was meant to be a book that can maybe interesting also for people who don't know system theory. For many reasons we can discuss, but for people knowing system theory, it's for me a pleasure to point out how the entire structure of the book, the basic idea, everything comes from system theory. I can think only in theoretical terms, and my reference tends to be always referred to system theory. Just a couple of words on that. The idea, now takes the name artificial communication. We can talk about it. I don't know how happy I am with the idea, because the artificial communication has as idea, I think, can be useful. I can try to argue why, but it has some problems, which I would like to discuss with you as well. But the idea came much before the book, because I started thinking about these related topics back in the 1990s, so very long ago, where I was working on other topics, but I was very young, and I was making consulting at a computer firm, and so I got close in touch with people working. Now we talk about algorithms, then people talked about computer, but some problems were the same. And the 90s were the time where there was a lot of debate about strong AI, weak AI. Some of you might remember that. And also there was the idea, which is not so widespread now, that artificial intelligence had the goal to produce with digital tools a substitute or imitation or a simulation, whatever they said, of consciousness. So they were talking about artificial consciousness, which got lost. And of course, for us, the system theory was really a crazy idea. What does it mean? Do you want to produce a psychic system or something similar to that consciousness, Bewusstsein, with the artificial tools? What could it mean? And of course, for me, the idea was, from the very beginning, I had the feeling that something strange about it, or saying in a brutal way with Luhmann's idea, we already have 7 billion consciousness. They are all in transparency, they're not controllable, and that's how we really, it's important for us. Do you want to produce more of those incontrollable, obscure entities? For which purpose? Which kind of control? So it was a strange idea. And as I said, at the same time, I was doing this consulting in a firm which made, among other things, they made video games. And it was a very successful firm because of the guy who led the firm was, as people are in this field, a strange kind of genius in some way, had an idea. He also had chips that were sold also at Sony and all the producers of video games in the world. And the problem at the time, the computers were much less powerful than what we have now. So we had to work with limited computing power, and to have machines, video games that were entertaining for the users. So they had to be unpredictable. They had to be fun, surprising, and so on, but not completely, because at the end you have to win. It was the thing that were arcades using in this saloon where you went. No? And the real problem at the time was to produce randomizing machine, so random generator, to have something that makes the machine unpredictable through something similar. The machines are completely, of course, determined, but to produce something which looks like it was random or surprising for the user. Sorry, I take it far away, but we'll see how it goes to our point. And this guy had the idea to use, to make the machine unpredictable or random, to use the behavior of the players. So he used the minimal movement that the player had. At the time, they used joysticks. So, and you always have, in the way you interact with the machine, some unpredictable, different, we would say contingent kind of behavior. And so he used the unpredictability of the behavior of the user to make the machine unpredictable for the user. So the machine became much more fun, and you saved a lot of computing capability reflecting the behavior of the user to make the machine sort of, you know the game. And that was hugely successful. So it was much cheaper, and that was what you said to Sony and so on. It was a very, very successful way to stage this sort of, we say, interaction between these video games, the machines, and the users. And that's where the idea that in the book, I quote it now, but in the book, the idea of virtual contingency came from. So the idea that the machine doesn't have to be intelligent by itself, but can act as if it were intelligent, using the intelligence of the user, reflecting it in a way. And these reflections was actually virtual is a strange concept, but by virtuality, I was from the very beginning interested in the idea of mirroring what is which is always in virtuality, because the concept of virtuality comes from optic, and it used to indicate the images in a mirror. In the visual mirror are virtual images, because in the mirror, the object is not on the other side, and because the light ray go through the object. There are physical reasons for that. No? In any case, these virtual images are the images produced in a mirror. So I thought it can be interesting, because what I wanted to work is this idea, this mirroring of the machines, of the behavior of the users, in order to machine to become interesting, as actually, and to convey information you cannot have otherwise, like the mirror, because in the mirror, you can look at yourself from a different perspective. You're not going the other side of the mirror. You stay there, and you can look at something you couldn't look at. You sort of explore yourself in a different way. And that was the basic idea that happened in the 90s, which didn't go much farther because I didn't have time to work on that. I worked on other topics. With some people, with Dominic maybe knows it, Gunther Küppers in Bielefeld, we thought we make a research project, but at the end, it simply we forgot it. It was lost. We didn't go anywhere until well, like 20 years ago, like in the 2010. So when completely independent of that, the development of computerization, of digitalization took a different way. The one we are now. And I said, everybody says we are now in a spring of artificial intelligence. Now we talk of algorithms, not of computers, but the machine seems now to be so able to interact, to act as communication partner, we talk about it a little more, that the idea is very widespread. The machine now seems to have become intelligent. And that was the reason of the book, because we can discuss it, but the very simple main idea of the book, that machines are not intelligent, don't have to be intelligent. They have not learned to become intelligent, but have learned to communicate with us using, like in the sense like the video games at the time, parasitically using, through this idea of virtual contingency, the behavior of the users that now, different than from the 90s, is available on the web. So basically the situation I was thinking about in the 90s was not easy to empirically show at the time, but then machine learning came, by which the machine are much more able to process information, and most of all, big data came with the Web 2.0 that makes the information produced by each of us available to the machine to process it and to be able finally to act as a really, well, as a communication partner, as if they were intelligent. But the point of the book to show how they don't have to be intelligent, have to be learned how to communicate. The shift from intelligence to communication. That the question, what I want to, since we are on the system theory, I want to point out, if I have a couple minutes more, maybe, shall I? Yeah. I want to point out where the idea came, where the connection with Luhmann is connected, because we know, okay, the machine produces information with a efficacy and a speed, and so it was unprecedented before. But we know in that frame of system theory, why talk about communication? How do we deal with that? The problem I had at the time is how can we describe with the tools of system theory what's going on with these very, very effective algorithms? And of course, communication is not the only possible concept, because there's a lot of information which is produced with and is processed in society that doesn't require necessarily communication. Well, this typical example, I have information through my watch every day, and I know that now it's 6:30 is information, and the watch produces the information, but I don't communicate with my watch. So as we don't communicate, we don't need to communicate with the computing machines that, not computers, the machines that calculate and make calculations on, multiply numbers and so on. All these machines exist since a long time. They produce information, but actually it doesn't make a lot of sense to think about communication. I never thought that we are communicating. For many reasons, the sense of system theory, we're not communicating with our watches, we're not communicating with computing machines. Why then try to play with the idea that we might be communicating with computers or with these new algorithms where they use machine learning, big data, these new effective algorithms? Because I wanted to deal with something which didn't exist before and seemed to be possible now. First, that we have with this machine a contingent reactant to contingent behavior. That's what I was trying to describe with virtual contingency, because the machine doesn't, what you have is what you get as a reply from the machine, for example, the search engine or other tools that we will interact, is something, it's not an information that was available before, but it's an information which is produced in the interaction with the user. So it's something that I know the differences, but it somehow reproduces a situation of communication that whereby the information is produced in the course of interaction. And we contingently ask questions to the machine, and the machine produces a contingent reply that didn't exist before the interaction. And that's different from a computing machine or a watch, which was programmed from the very beginning to produce something. Without the input that we give to the machine, the answer wouldn't be there, because the answer is always different, as exchange, communicative exchange is different from time to time. And that's something new with the computers. The other aspect is, which is connected with that, that in this case, not in the case of the watch, not in the case of other similar devices, you cannot attribute the communication to anyone else other than algorithms. So in a sense, the information is produced by the algorithms. It was not there before. The programmer didn't know the answer. The people who put the data, prepared the data set, didn't know the answer. This information is produced by the machine with a lot of inputs that we try to describe. But in a sense, that's also unprecedented. You cannot say that it's, okay, in a sense, it's an unprecedented situation that I wanted to try to describe. Therefore, I said, let's try to work with the idea of communication. Even if I'm completely aware, not all features of communication are there. It's a strange communication. And the question is open that I want to discuss it out. Is it worth talking of communication? I decided to try to do it. That's why the title of the book, but I know that some aspects are still open. So the reason why I tried is, well, of course, because we have Luhmann's idea of communication, of course, otherwise it wouldn't make any sense without Luhmann. And Luhmann's idea of communication, as you perfectly know, starts from the receiver. So in a sense, it's much more open towards what happens on the other side. So Luhmann, of course, it was provocative, but said in ancient societies, one could communicate with burning bushes, with birds, and so on. If you interpret something happening in the environment as communication, through gods, through animistic things, from whatever you do, but if you can interpret this behavior as communication, it is communication in society. And Luhmann said, in ancient society, you could communicate with birds, with stones, with whatever. No? And then the evolution of communication in society made these things impossible. So in a sense, the concept had a sort of flexibility. As Luhmann said, of course, it was a joke, but it's a very interesting one. You know the question of communication with Zettelkasten. Luhmann said, I communicate with my file cards because, for this reason, in a sense, because through this strange arrangement, you get information that nobody else produced besides this strange arrangement in the Zettelkasten that you activate with your question. Well, that was partly a joke, but so to say, Luhmann always said the tools, so the concepts are tools in the theory, are flexible, they have to be used, they have to be changed, and please try to experiment with that. So I said, let's try to do it on one hand. But of course, I'm aware that, as I said once more, I'm not really sure that if it is communication, a different kind of communication, because there are some defining feature of communications, we know it, as a structural coupling with the psychic system, that of course are not given with the machines. The machine is not an alter ego. In the way we communicate is even in a written form or so on, the idea that the part is an alter ego is constituting element of communication, which of course when the computer is not there. It can happen, but okay, children communicate with their stuffed animals, okay, but that's not the point with the computer. We don't interpret the computer as an alter ego. Therefore, that's something that Luhmann wrote in a book, in a note. So it said, in the case of computer, the novelty could be that the traditional unity between Mitteilung and information is not there anymore, because it says that all the concepts. So communication happens when someone understands the difference between information and Mitteilung, and which means that you get an information which is sort of colored by the reference to the Mitteilung. To interpret the information as information mitgeteilt by someone else, with his perspective also, the meaning of the information is connecting with the Mitteilung. That's how information works, or communication works. That's why the information is different, all the things. No? And that's not given, of course, in the case of computers, because the information you get is not referred to the mid-tilum because there's no real mid-tilum from the computer. So of course you can try to understand how the machine works. And now we have the big project in Bielefeld about explainable machines, explainable AI. How you can somehow make sense of the procedure of the machine, but in any case, something different. You are not referring to the idea that the machine meant something, wanted to something. I don't have to go further. So that's something which is not given there. No? So for a while, I even said that if we talk with artificial communication, we have the idea is sort of asymmetrical. We could say that. But I tell you all the things are all open things. That's what I thought about it. But I'm happy to discuss each of these decisions. That you could even say that we communicate with the machines don't communicate with us. That the asymmetry, the difference with this kind of communication and the communications we know. The communications we know, both parties communicate in a sense. Besides some exception, you are mistaken, the people don't want to talk and so on. But while with the machines, we communicate with the machines because we are the receiver, and communication happens when the receiver interprets, processes, not as communication, something that happens. But the computer doesn't make any sense to say that they communicate, they just work, their machines, and that's their strength in a sense. So this is the background. Last little point, the reason why I decided it, because I was irritated by the overall debate about artificial intelligence, because the machines are not intelligent, they want to be intelligent, it's not a way to understand what's going on. But the question that we as sociologists has to ask, or that I felt as a sociologist want to ask myself, is not, is the machine intelligence becoming intelligent, which is, first boring and doesn't bring anything, and for me it doesn't make a lot of sense. Besides some dystopic, strange ideas that don't bring anything. But the question that I really want to ask is another one. What does society change when computers are there? And so the question, that's why I decided after all to use the idea of communication, that the idea that these tools are changing communication society. If our object is society, and society, the autopoiesis of communication, how communication is anxious phases, connected, how communication is produced and elaborated in our society. In a way, the presence of these algorithms has an effect on the way how communication works in our society, how society is made. That's what the main reason that brought me to try to experiment with the idea of communication. But the main idea was to shift the focus from the useless idea of intelligence to something where I don't know where it will lead, but it seems to me more productive to focus on how communication is changing. And to end, for example, our project on predictions goes in the direction, and the sort of not well organized, but the different chapters of the book try all to use this idea. What happens when we observe what's going on with algorithms, not referring to intelligence, but referring to communication. And the project we are doing on artificial, explainable AI is also the idea, the same idea, how to interpret explainable AI, not in sense of explaining intelligence, but in the sense how can machine produce a communicative explanation, which change completely the setting, actually. So that's it. Sorry, it was longer than I meant to talk.
No, thank you so much. I think it was absolutely perfect as an introduction for the discussion. Thanks a lot, and I found it fascinating what you said. I might have learned more than I would have from a presentation. And I would just open the floor for everybody else to talk, to give the comments, to ask the questions. Yeah. Okay, so the first hand I see is by Jose Javier Blanco Rivero.
Thank you, Dominic. Thank you, Elena, for this position. I've been reading your work for many years. I remember in 2017 that you published an article that explore these issues. And of course, I've been studying Luhmann theory for more than a decade. So this position, the issues we're dealing with are quite exciting for me, and I think I have a lot to say. I would like to organize my intervention by pointing the issues, the most relevant issues that you wanted to stress. The first one is the fact that artificial intelligence has succeeded as long as it waned in its intention to imitate human intelligence. I had this thought on my own, I remember some time ago, and I see that you make this point too, and it makes a lot of sense to me. However, I find that this intention is still alive in the program, in the research program, or AGI, or Artificial General Intelligence. And in the field of AI, there's also this research line following the ideas of Douglas Hofstadter, where the scientists have been digging into the concept of cognition and its relation to computation, and how these two concepts differ, and in which sense computation is some kind of cognition, and cognition can be seen as some kind of computation. Julia Pearl, who is considered by some the father of modern AI, recently published with another author a book called The Book of Why, where he tries to redefine cognition, in terms of causation. And he talks of the ladder of causation, prediction, intervention, and imagination. And he says humans are intelligent because they climb over this ladder of causation. But artificial intelligence still cannot reach imagination. It sometimes can reach intervention, but how could I say? It plays its role primarily at the level of prediction. Also, Melanie Mitchell published a book about artificial intelligence, a guide for thinking humans. And she also deals with the issue of the limits of artificial intelligence, but she also tries to tackle this problem that is so, how could I say, is so proper of the field of artificial intelligence. This is what you mentioned about this cycle of springs and winters of artificial intelligence. We in the jargon of Luhmann theory could talk about the inflation of expectations. Yes, the communication about artificial intelligence tends to fall into these cycles of inflation and deflation. And she tries to tackle this issue, but it's a book written for a great public. And she tries to lower the expectations about artificial intelligence in order to try to break this cycle in some sense. So my point here is there is this, I think the leader, how could I say, some researchers in artificial intelligence, top-notch researchers in artificial intelligence, are pretty conscious of the limits of artificial intelligence, but still they are trying to reach AGI, artificial general intelligence, and they are trying to do so even by redefining cognition or furthering our understanding of cognition. So I think this debate about if we shall imitate human intelligence or not, there's still years to come with this debate. Still, I agree that the metaphor of intelligence and the metaphor of the brain is no longer productive in this field. It is a dead metaphor in Paul Ricoeur's sense. And I believe the concept of extended cognition could be more promising, but well, that's another distinction. That's another discussion. Another issue I would like to raise is about what you say about the concept of communication in human and its suitability for dealing with algorithms. Well, it's more kind of a discussion, no? But just suggest in your book that the concept of communication of Luhmann is suitable for this discussion because it decouples consciousness from the process of communication. And I agree with this. However, I would argue that we shall not focus on algorithms, but because algorithms are part of a bigger whole, and that is software systems. Therefore, I believe, and this is a research I've been doing in the last couple of years, we could explore software as a communication medium, as long as it's capable of becoming an information source by the interplay between loosely and tightly coupled elements. For example, loosely coupled elements in the software industry are the APIs, application programming interfaces. And through APIs, you can build any application you like. These APIs are services other programs offer a service. And I think the world of software has the properties that in Luhmann theory we ascribe to dissemination media or Verbreitungsmedien in German. Furthermore, Luhmann sociology, sorry, I will not like to stand too much, but I will finish. Luhmann sociology of communication can also shed light on the interaction with AI-powered systems. Luhmann argued that communication is structured by expectations, and the interaction with artificial intelligence is highly structured. And I believe that structure that is at least in part hard-coded into the systems. For instance, I had a chance to chat with this application of OpenAI, ChatGPT, and you could realize that its answers respond to a template, to a sort of template. Of course, they are different. You can even hit the button retry, I'm sorry, and it gives you a different answer. But I even went further and asked ChatGPT if it had a template for providing answers, and the answer was yes. It said, I first provide some background, then I provide some definitions, and something that it didn't say that it always apologizes, and then it explains that it is an artificial, well, not an artificial intelligence. It doesn't say that explicitly, but it says that there is a sort of technology that is not a human being. That it explains its limitation. It obeys a sort of template, sort of structure, and I think that Luhmann pointed out how communication is structured. It is structured by expectations. And if we think about expectations and we think, but can a computer participate in expectations? Can it anticipate expectations? In a certain way, it can. I believe it can, because it reduces the problem of expectations to a problem of probability of word occurrence. It calculates the probability of a word or of a set of words of occurring as the next possible phrase, for instance. Well, I excuse myself. There's a lot I would like to say about this issue that excites me a lot, but I don't want to abuse. So thank you.
Thank you. So I think maybe we'll have the opportunity later on, but the idea is for everybody to get the opportunity to speak. So
Sure.
in terms of just keeping it to a conversation instead of a series of talks, maybe my idea would be, if you agree, of course you can diverge from it, but my idea would be to give you, Elena, the possibility, since you were addressed more or less directly with the questions, to pick from the topics which one you would like to discuss or to respond to. Artificial general intelligence, software as medium of communication, or the question of expectations in interactions with algorithms, and maybe then from there on we can lead into a discussion.
Yeah, thank you. It's always nice to be able to reply immediately, and that one gets confused when there are too many questions. And I want to answer to everything was too much. There were so many interesting points. I try to be quick, and just that, of course, I won't be exhaustive, but just say something. There are really, really good, interesting points. You're right. People still go on talking about artificial intelligence, even if the idea that the machines are not intelligent has been raised since long. People know the machines are not intelligent, but still the idea is that they talk about the limits of artificial intelligence, that they are not really intelligent, but when will we reach the intelligence on. And for me, it's a really strange discourse, because I wouldn't talk about the limits of artificial intelligence. They are not limited intelligence. They are doing something different. The point is that they don't try to reproduce. Now, if you look at it, they don't try to reproduce artificial intelligence. They are not, or they say, oh, they are stupid. They are not intelligent, not either stupid. They are simply machines. They do something completely different. So it's not, the categories intelligent or stupid are not proper to dealing with machines. And I have the impression that people keep using that, or to put in a very blunt, simple way, because they have an alternative. Since the machine do what we do with intelligence, it's a way or the other, you have to compare them with intelligence. That's why I think that communication can be an alternative. Because take, for example, the Turing test. Why they keep referring to the Turing test, which is nowadays is completely outdated, because the machine passes the Turing test every day. Think about this OpenAI, this ChatGPT. So that's, of course, it's passes the Turing test completely if you don't know that that's a machine. So you wouldn't realize that the machine is there. No? But the Turing test is actually a strange test, because you think about it, we already discussed it. It doesn't calculate, it doesn't test intelligence at all. It tests, you know how it goes. The machine passes the test if the partner doesn't realize its communication partner is communicating with the machine, which means it's a test for communication capability, not for intelligence. So, and actually, I think that's a shift in the thing would help solve a lot of questions. For example, Judaia's Pearl, the idea of the Book of Why. I read it too. For me, it was terribly disappointing. He's very, very clever. The point is there. But actually, the entire point is to couple for me, particularly interesting, we work on prediction, and to couple prediction to causality, where of course that's not the point, because the really interesting debate for me now is, which is not my idea, but I use it a lot. That's a really interesting debate in the computer science community, saying that now they're really completely separating prediction from causality, or prediction from explanation. The idea is, which I think is the point here, that plays out so many things. Pearl is right. The machine is not able to understand, to reconstruct causal links. It's only able to predict. And that's the point, actually, you are saying. You don't need to understand in order to be able to predict. You can predict without understanding. And that's I think that's another fascinating trend now, that what in statistics has always been a mistake. You say correlation is not causation. Now that's the strength of the machine, because they don't need causation. They don't need Peirce's idea in order to work. They just need correlation. If you have a good correlation, due to the correlation, they are reliable. Even the machine is obscure, you can make prediction even if you don't understand. So you are relieved of the terrible burden of understanding. The machines are so efficient, and that's the limit that they're not intelligent. They don't need to be intelligent. That's a great strength of the machines. That's why I think the debate is sort of strange. Very quick to another question, because sorry, I didn't answer all of it, but can software be understood as a communication medium? I agree with you. Of course, a communication medium, not in the sense of a false media, not the symbolic generalized mediums. That's not the point. It would be Febvraio's medium, diffusion medium. I would go in this direction. But the question by Luhmann was, Luhmann had all this wonderful thing that said, Problembezug. You have to know what you gain if you use a concept. No? And the Febvraio's medium, all of them answered to a question. They were there to deal with one different form of improbability of communication. In the case of writing to reach a person very far away, there's a printing press, the mass media, and so on. So the question is, if we understand, which I don't think is wrong, but the question for me is open, in order to speak of software of this, software evolution, so as communication medium, different from communication we already have, we need an answer to the question, which kind of improbability does this medium not eliminate, but deal with, in a sense, make more likely something which otherwise would be unlikely. What is it? I don't say no. The question I asked, let's go in this direction and try to find out if it's worthwhile thinking about communication medium.
Jorge Galindo.
Yes, thank you. Hi, Elena. I'm very glad to see you again. Earlier this week, I attended to the other seminar, the Society and Technology seminar. So this has been my Elena Esposito week, and I'm very, very happy for it. I have already congratulated you for this wonderful book and mentioned that I hope it becomes the arrowhead to introduce the capabilities of systems theory into the English-speaking sociology world, because, well, I will have to tell you many things about my own experience in the United States, but social systems theory there is practically non-existent, but well, this is a topic about other stuff and about other talk. I want to mention as well that this that I am thrilled to see how deeply sociological and theoretical this book is, because as you were mentioning before, for people who are not acquainted with systems theory, it is very clear. It is a very book that is relatively easy to understand. But for us, for the people who know systems theory, we see all these tools here and there, contingency, communication, paradoxes, everything. So it is kind of like looking for clues. Sometimes you can almost anticipate what is going to appear, because you say, now she's going to say something about a paradox, and it appears. Now, or for me, for example, I love Goffman as well. And when you talk about Goffman, when you cite Goffman, it was very interesting as well. And now, after this kind of introduction, 3 questions. To me, it is very clear, and I agree, as you say, that web communication medium is not a mass medium in the traditional sense. But you can you tell us more why this book could not have been a chapter in the Realität der Massenmedien? I mean, why this book is different from the arguments of Luhmann in that book? The second question is, do you think that there could actually be a convergence between your own diagnosis and the one developed recently by Habermas in his new book about ein neuer Strukturwandel der Öffentlichkeit? I mean, do you think that this thing about the public sphere, do you think that there could actually be a convergence between the 2 old foes, systems theory and critical theory, just as a sort of speaking, I mean? And then when I have more questions, but I want to mention this one. This is not a question about the world as we are living it now, but it's kind of a sci-fi question for the future. But I think that it could be very interesting to know what you think about it. Do you think that neuroprosthetics would mean the end of society or social systems in the way that we know it? Because if we can translate thoughts into communication with a machine, I mean, what would that mean for double contingency, for example? Would there still be a double contingency? I don't know. I mean, this is something that I know that it is a very tricky question, but I would like to know your opinion about it if you have anything to say. Thank you very much.
Thanks so much again. They are, again, really, really interesting questions. I do what I can to answer that and try to be quick. Could the idea of artificial communication, what happened now with the algorithms, fit into reality the mass media, Luhmann's book on the mass media? Well, Luhmann is Luhmann, so of course, that's not, but let's say in the kind of discourse, no? Yes, I would say yes, in a sense. I would say what's happening now. Well, I say they're not. The web is not a mass medium. On the one hand, yes, because it's not the mass media like the other ones, because the mass media refer to it has some features that are not given now in the web. Most of all, it's not mass, because the communication is personalized, it's different for everyone, which all the consequences will be we are dealing with. The social media are not broadcast media. That's the strength that they are presented as such, which a lot of consequences. That's also refer to the second question, the idea of the public opinion, the public sphere. Everything is different with this medium. But in a sense, I see it as an evolution of the mass media. So it would go. It, in a sense, is the evolution of what was going. So I would the kind of discourse fits in the discourse about media. So it would be definitely the frame in which to deal with this question. And I think that's a really interesting, important debate there. The difference is only that, well, mass media are one aspect, but the media, the one is a factual subsystem, but the different media are also varietous media. They have consequences in the very different functional subsystem independent of the mass media. So the printing press changed, produced what then became the mass media, but changed the economy, science, the arts. So that it's sort of and now the algorithm has a double identity as something like a different varietous medium in a sense, or something going this direction, but also something that changes the communication, the functional subsystem of the mass media. And the two aspects have to be kept separate. And still the situation is very fluid on the thing. Habermas about the strukturelle Öffentlichkeit, what's happening. Well, that the public sphere, not only the public opinion of course, but also the public sphere is changing with the algorithm is clear. And that's a huge problem for our society, for democracy, for many things. And I think the idea of the filter bubbles, which is not theoretically elaborated as it should, it's something new. So the idea of this echo chambers, filter bubble, they change actually the structure of the public sphere in a deep, deep way. But I read this article by Habermas, and he says that you have a plurality of public spheres. And that's, for me, actually doesn't make a lot of sense. Because that's not a way to deal with the filter bubbles. They are not a plurality of public spheres. They are a plurality of circles of people with generally not the anonymity and not what the real point of the public sphere, Luhmann, is he presented in mass media, which I think for me, well, actually on the public sphere is one of the points where critical theory, Habermas and Luhmann are not so far away, because the only book of Habermas for me I can do something with is the Strukturelle Öffentlichkeit. The other ones I can simply read them because the idea is good. Actually, it's connected with then what the consequence of that is. But there are a lot of interesting things about that. No? But in terms of Luhmann, the real point about the public sphere is that the creation of second reality with no Konsenspflicht, no mandatory obligation of consent. And that's the point, that you know what the other know without knowing what they mean and what they want. And so the other is really anonymous. And that produces sort of a reference to other people you feel connected with the anonymity as a strength in the way the public sphere. And this, you cannot have a plurality of public spheres because they are sort of how the filter bubbles are presented. They're a sort of assumption of consent in the filter bubble because the people are, in a sense, the filter bubble referred to shared values and so on. It's not something which is the idea of the, and in any case, it destroys the fiction or the idea of the modern public spheres or the public opinion as well, where you think, I feel connected with all the people that know what I know, even if I know what they think about it. Because in these cases, the filter bubble, people don't know the same things. It's simply, it's not a social element. So, to put it very quickly, it's a huge problem. I think the system theory has a lot to do on that. And I know Giancarlo Corsi is working on this, so we are waiting to see what comes out. But that I think that the system theory should work on the public opinion. And that's something that really needs to be done with the theoretical tools more elaborate we have now. Plurality of public sphere, I wouldn't go in this direction. Prosthetic, I don't know. I don't know, because if you have a chip here, I want to see how communication changes, and that still remains a psychic process.
So,
Thank you.
Just make a small try again. Of course, I understand that everybody wants to get their comments and questions in, and I will not restrict you in it, but if you can maybe just make one comment to what has been said, ideally, it would be even more welcome. So we can really have maybe even more of a conversation, and of course, everybody can speak more than once. So Aldo Mascarenhas.
Thank you. Yes, communication cannot control itself, says Luhmann. Regarding the first discussion on artificial intelligence, maybe I would resolve this with whether artificial intelligence is intelligence or not, or is the communication the concept that we must focus on, with a sort of, so to speak, Luhmannian irony that there are humans that are more intelligent than others. So surely there are computers that are more intelligent than others. And end of the discussion, I would say that there is more power in the concept of communication than in the concept of intelligence. This is not a theoretical concept in the discussion of artificial intelligence. But my point is not that was just a comment on the previous discussion on artificial intelligence, or whether intelligence or communication. That's communication, of course. But I would like to focus, Elena, on the relationship between these forms of algorithmic analysis and production of sociological knowledge. And when you, as you know, when a system theorist speaks of sociology, he or she speaks of system theory. No? So what is the relation on the power of artificial intelligence to prove, to test, to increase the knowledge coming from systems theory? And I would say there is two chapters in your book, the chapter 3 and chapter 7, which deal with that problem. And the chapter 3 seems to me very clear potentialities in the text analysis, as you mentioned. But I have a question there, because the problem in text analysis with algorithms is not the problem of reading. There is a sort of reading in artificial intelligence or in algorithmic reading. The problem is how, because the reading is always produced by the theorists and by the theory behind the theorist. So the interpretation is produced by system theory in case of system theoretica. So in that sense, so it's not a form of reading, but the way in which algorithms help in discovering what I would call semantic patterns, semantic distinctions or discourses in a way. So when you want to use this concept, but semantic patterns is the best description in system theory. So and it seems to me that there is a great advantage. This reading is not. We have not to expect in algorithms a reading of algorithms full of meaning, but the capture of meaning in patterns devoid of individual authorship, so to speak. So the movement, so to speak, of semantics. So, for example, I was thinking how it could be if we rewrite or if we rehearse a new investigation on love as passion, for example, with algorithms, with semantic algorithms. That will be really different because we can include a lot of different sources, not only text analysis, but also images, but also, I don't know, social network analysis, and I don't know, pictures and movies and soap operas in the present, so whatever we can analyze. So the problem is not reading in that sense, but the discovering of semantic patterns. And in the 7th chapter, I guess that there is a sort of I found that the comparison between the divinatory procedures and algorithmic prediction is a bit unfair. It's a bit unfair because it's true that the divinatory procedures did not provide explanations, as you mentioned, but correlation as algorithms do in prediction. But it seems to me that the problem is that we are used to understand science in the classical fashion as producing explanation, as producing causal explanations, such as those of statistics or economics. So that what one could see that there is a loss of scientific capacity, if it's only about semantic or behavioral patterns in our analysis and not about causalities. So, but when it comes to complexity, and this is the point, there is no causal explanations. Explanation is, as Maturana said, for example, so the ability to recreate how the phenomenon, the social phenomenon or the empirical phenomenon emerges in the explanation. So this is the concept, I would say, of scientific explanation when we have as a focus a complex system. It is not causality, but reconstructive description. In the description, we have to make as if the phenomenon emerges, and I think that this is the best way to reconstruct this complexity is through this investigation through algorithms, better than the scientific causalities, better than the statistics. Is focusing on the semantic and behavioral patterns that through algorithms we now can observe. I think that this is the best way today to make system theory.
Shall I? Yeah, that's really challenging because they are so interesting, complex questions, and try to answer I see time is going, but okay, I try to do what I want. That's a very interesting point. Very short about the first one, short comment, was not a question about intelligence. I think the point is not if machines are some more or less intelligent. The point is I really think that the real difference is intelligence as a concept to build artificially is a strange idea, because nobody knows what intelligence is. There's no shared definition of intelligence. So that while we know quite well, the definition of communication are different, but there's an object we can observe. There's a lot of studies. We know how communication works, how it changes, and so on. While with intelligence, it really, so reproducing with machines, something we don't know what it is a strange idea. So a shift to communication advantage also for this reason, but that's a little remark. Reading. I completely agree with you, and the reason why I found this debate, that's a huge debate in literary study about distant reading, the Franco Moretti ideas, and how machines, Lev Manovich, how machines are able to process huge amounts of text and allow us to get information from text that wouldn't be possible without machine processing. So you can see, well, you can study, well, you said patterns in a single book that were impossible to find otherwise. You can find patterns across books, because as Manovich said, you can process 1 million different mangas, in his case of text, and to find correlation between the text and get information that are relevant for our understanding of written materials, understanding of text. But the idea that people say, oh, now machine can read. That makes no sense. Machines don't read. Actually, even if we claim the machine communicate, I don't think it makes sense to make that's how the concept of communication becomes slippery. No? Machine doesn't read, but communication changes again. Things, but the way how we deal with text, how at the level of society can get information from text changes. So that's why in the book I use this strange formulation that's, I mean, again, you need a system theory as a background, that algorithmic reading, that already our society is realizing for algorithmic reading, but algorithm reading is not algorithms reading. But I think it's got the direction you were saying, because algorithms are able to process text in a way that was not possible before, finding patterns not only at the level of syntax or level of the words, but also at the level of meaning, because they are able to say, you can find semantic patterns through different texts in the same text, and would be able, I think so also, to deal with the topic like love in a way that can become extremely instructive. You can know much more about the text. But who reads are then the human, the scholars. So that, I mean, our society can use the process of the machine to get information from text, and society at itself, communication, are able to get information from books in a way that were not possible before. But that's the change at the level of communication. It's again one of the cases where the machine itself doesn't read, but the reading process in our society changes. But the way we elaborate what comes from the text becomes at the level of general processing more complex. And that's one of the cases where I think it's shifting clarifying these ideas is interesting. And some people so many people propose to have a broader idea of reading that includes also machine able to read, otherwise you put anthropomorphic blindness, not accepting machines reading. I think that sort of goes in the direction of hybrids, that are very hybrid idea of reading. I don't agree. But the communication remains a communication. It is a communication, but it can be processed in a more complex way. So I agree with you in the way how to deal with that. Divination, I think that's a slight misunderstanding, because when I say that algorithms resemble divinatory feature, it's simply what I observed, because they have some features that we have, the strange feature of algorithms that rely on correlation, that are obscure, not understandable, and most of all, that they refer not to average values, but to individual things. The algorithm tells something about the individual, not about a group and so on, which are really new features that correspond to our don't correspond to our scientific explanation. They are more they don't have these features. Doesn't mean that we have to go back to divination, but rather that I would say that our scientific rationality was established marginalizing divination as a form of irrational procedure. And that might not be needed anymore. But it means, of course, our scientific rationality remains, but we might be able to take advantage of some forms, of course, with all the differences, because the relation with time, with eternity, with God is completely different in a divinatory mind frame. But to take advantage of some forms and structures of divinatory procedures to deal with algorithms. So the debate with the article, the debate ignited by Chris Anderson with the end of theory. With algorithm, we don't need theory anymore. We don't need explanation. We just need correlations, and that's enough. Nobody agrees today with that. But the idea is algorithm can work only with correlation. We take it seriously. But the correlation, as I think you were implying, can be used also to produce better explanations. Machines don't have to explain. They do correlation. That's our job. It's good enough. It can be really extremely useful. And we care a lot from the correlation, not because theories are not needed, but not always needed. For example, if we need predictions, a correlation might be enough. But in many other cases, we need to explain, and we can explain because we have scientific rationality since modern time. We can still use it, and maybe start from the correlation found with the algorithms to find better explanation in some cases. That's a more complex idea. So don't give up, summing up, don't give up scientific rationality to go back to divination, but in a way have tools like algorithms that are produced by scientific rationality, and that they're so powerful that we can even now be able to re-evaluate, rediscover some forms of divinatory reasoning that was marginalized for a long time.
Gaston Becerra.
Sí. Thank you, Dominic. Thank you, Carlos, and of course, thank you, Elena, for letting us discuss this book. I really enjoyed the book. I really enjoyed that it's not an easy book. If you want to get a simple position in terms of if it shows us an optimistic or pessimistic view of these technological changes, but I think there is perhaps one sentence that somehow kind of has an evaluative charge. And I think that probably this is the sentence that a lot of people have asked you about. That's on the page 5, that says that perhaps the society as a whole is becoming smarter by this artificial communication. And I was wondering if that's not I don't know, some sort of evaluative assessment.
You're right. That's very clever. But the easy answer would be, is smarter evaluative? Is it necessarily better to become smarter? It's not necessarily better, but that would be sort of an unfair answer. No? I think that the point, it's an easy formulation. But what I had in mind was, I think, if I understand it right, was Aldo Mascarenhas was saying that the process, we don't know what intelligence is, but in any case, the information circulating, the process, what with the complexity of the dealing with the information with data and so on is increasing in our society. If that's what we want to understand as smarter, but not because people have become smarter, but because the communication is becoming smarter. Sort of, in a sense, how, for example, in the case of memory, since writing, alphabetic writing, as Plato's argument and so on, individual people lost their memorizing ability, but society as a whole increased a lot the ability to increase memory. So we don't remember almost anything compared to people in pre-literate cultures, but we have much more information available because we have all the information that are not stored in our mind. So something in this case, society has become much stronger memory with the printing press, with the writing and printing press. In a sense, society, whatever we mean with smart, can become smarter, even if the machines themselves don't need to be smart.
Okay, so now I think we've made the round, and Rosario Rogel has been very patient.
Hi, Elena. I'm really glad to read your book. First of all, I want to thank that this book is in open access, because this allows us to read it in a very quick way. There's a lot of books that are interesting, but they are not in open access. Then I, as a reader, really appreciate this I don't know, this not only for you, but for the MIT Press. I think this is a really great option. And okay, then thinking about this, I've been working and studying topics related with open access and open science, exactly for this kind of things. And when I read your book, not only your book, but the previous articles that you have published in different journals talking about this topic, in different places, I've been thinking on the way in which the science communication has been changed with all these electronic stuffs. And I don't think about this like if the algorithms or there is the artificial intelligence or something like that, but I think there's something that is changing and we need to notice this. For example, when I've been reading your book, and at the same time I'm thinking in the different ways in which the open science practice has been involved in the way in which we work, it is really clear the way in which the communication has been changed. For example, when we have these new ways of publishing, like the preprint publish, there's some article that you finish to write or you are writing, and then you put into a repository, but before the peer review process has approved, have approved this article, then probably this article has been rejected, but is still in the repository. Then this something strange is happening, because in the normal way of communication for the science communication, you have an article, and then this article is approved or not by the peer review, and after that, this is science, and can be communicated. But when all these electronic communication are involved, then suddenly you have something that is not, science approved, but is still in the field, is still in the system. Then I'm thinking about this, not only about the algorithm, this algorithm or this computer that is thinking, but in the way in which are changing the way in which we are communicated, and the way in which all of these activities must be taken into account. I mean, what do you think about this? What do you think about all these open, science, different activities or different practices has been changing, at least in this part, in the science communication? Have you been thinking on this when you, decide, for example, that your book being in open access, or all these things? What do you think about this?
Thanks again. It's a really, really interesting point. That's thank you. Well, I understand most of you said as a commentary, as an additional argument more than a question, because I agree with everything what you say and think it's enormously interesting. What's going on in the scientific? Yeah, I think that's really a good example to say. Well, again, I repeat my point, but it's nothing new on this field. I think to understand how science is changing is useful to think in terms of communication instead of intelligence. But it's a very good example to show, as you said, that's in your words, that what is changing is the structure of communication. It's not you cannot describe what's going on referring to intelligence. That's not the point. It's the structure of communication which is changing. So it's a very, very good example on that. And it was not, I have to say, the really disappointing. I think that a period open access at MIT Press it simply happened. So I was happy to do that, but it was not a choice. Well, it's partly a choice because our research being financed by the European Research Council is luckily, the European Research Council is a great institution. And one of the conditions for the financing is that all the publications to be open access. So it happened by chance to have the communication with MIT Press together with the grant. But I would have had, for example, the book has been published into Italian, and I have to have a specific deal with the publisher that has to be open access. That's what the European Research Council requires. But I'm happy about it. So it's a great thing. And what I know, I haven't worked especially on that, but I follow the great research on this. That's Sabina Leonelli in Exeter, who has work on that a lot of time, and they study mostly natural sciences, but they study, for example, how the nature of data and the structure of data, as you say, in open data, open science, changes the structure of research. What happens when you can make your research, you are a biologist or something, and you can use data that you didn't gather yourself, which is completely different. You can use data accessible there. How does it affect the way you prepare the data? Because to be open access, have to prepare in a different way, and the way how the people use this data formulate the research question. Do you form a different research question if you use open data or not? And how does it affect the development of scientific communication? They are great questions. So I'm not working on that, but I would love to, but you cannot do everything, but I follow that with a lot of interest. That's what you mentioned is another question, which is also very relevant, which is not exactly science, but a preprint, what happens. On one hand, I think it's really changing. If it gets established, it changes, let's use our terms, the autopoiesis of science, but not because of the autopoiesis itself, but because we have this, it has been established in the last 20, 30 years, this sort of policing attitude towards peer reviewing. So if you have a good idea, peer review will usually is innovative, is new, and peer review would usually cancel it. So because for many reasons you can observe it, which is a sort of, but that's not necessarily connected now with the new technologies. It's just it's a question of organizational theory, how the process of peer review in scientific communication has been sclerotized in a perverse way, because it's clear to everybody it doesn't work. Well, for many reasons, for the publication rules in academia, it's crazy. It doesn't work. It really doesn't work now, and it's not coordinated. But the new forms of making publication easily accessible, more are hopefully changed it a little, because in a sense, preprint means the autopoiesis of science can use things bypassing the gatekeeping role of peer review, if it happens now, because on the other hand, people need to have a position, and preprint does give you a position. You need in your CV, you need published stuff. So it's in a sense, it has a lot to happen still.
So we just passed the 90 minutes mark, I think. And of course, Elena, you have to tell me if we are taking too much advantage of your time. But if it's all right for you, I would just give the opportunity to 1 or 2 more reactions to what we talked about. And starting with Jose Javier Blanco.
Thank you, Dominic. I would like to briefly resume the issue about software of communication media, in part feeding on the intervention of Jorge too. And of course, with your, the point you made about what is the Problembezug of software as a medium of problem of reference in English. I believe that software deals with the code of information, and in the paper I wrote, I explored the idea of medial couplings, and that is the idea that Verbreitungsmedien, dissemination media, can couple with each other in the sense that, for example, a material that was written can also be sent to the printing press, can also be texted by messages, by messages can go over an email. And this is the idea of media coupling. How, let's put it bluntly, how a message can reproduce itself in different media, and each media has its own nuances in terms of interpretation and in terms of the form in which information is generated. And there's also the idea of the tentative structure, a tentative fractal structure of media. Well, I would not like to deepen in that. I would not like to provide a definite answer. I think the problem of which is the problema of software is really a guiding point in a research program. From in this sense is pretty valuable. And also I wanted to say we as system theories cannot do without tracing distinctions, drawing distinctions. And I think that there are two distinctions that are pretty important for our discussion. One is that between information and data. I believe information systems, although they're called information systems or software systems, they deal with data. They don't deal with information. If we treat information as it is treated in system theory, following Bateson as a difference that makes a difference, as a difference that makes a difference. I think other systems, be it psychic systems with consciousness or social systems, are needed to produce information, to draw that difference and produce informations out of that data. When you work in software, you work with functions that transform data. And in fact, there are design patterns that lead you to keep separated code from data. Data is data, and code only transform input data into output data. I think this is a pertinent distinction to make, that between information and data. And the other distinction is that between algorithms and heuristics. This is a distinction drawn also from Julia Pearl. Julia Pearl defines heuristics as, she says, heuristics stand for strategies using readily accessible, though loosely applicable information to control problem-solving processes in human beings and machine. Yeah, I think this distinction is pertinent because I have noticed in the social sciences discourse that the concept of algorithm has become a kind of a buzzword, and there are too many imprecisions in the discourse about algorithms in social science. Fortunately, in your book, it's not the case, but I have read many articles, and I believe the concept that social scientists get from of what an algorithm is and how it behaves is highly inaccurate. And I think this distinction can help, because when you write a software system, not everything in the software is an algorithm. There is too much use of heuristics, and there is simple use of conditional structures that have no particular fancy algorithm implied when writing it. And lastly, your chapter about Lisp, I find it very interesting. Where I missed the reference about Lisp that is the language invented by John McCarthy, who coined the term of artificial intelligence, and Lisp is a programming language, and it stands for list processing. And well, while I read this chapter, I was thinking, well, it would be nice to point out that the beginning of the idea of artificial intelligence started with the idea of list processing, of processing lists. Well, that will be all. Thank you.
Oh, I'm not muted. Well, about the last point, you are right. I didn't think about it. So I remember Lisp, that they were back in the 80s, people were using that. And I didn't know it was, well, yeah, thank you. That's a great idea. I didn't know that. I didn't think about it. And I didn't connect Lisp with Lisp, but great, you're right, completely. Great hint. About the other points, I absolutely agree with you with the information and data, and also how I would define exact information in terms of Bateson, so different that makes a difference. And I agree completely with you at the point that algorithm only process data. That's why also information requires much more, requires actually, I think it makes a difference referring to meaning, referring to something the machine don't use. And that's why, so I repeat myself, they don't need to be intelligent, do something else. That's why they work so well, because they don't need information, they process data. And also information for algorithm, what Algo Massalegno was saying about the reading, what the information in books, there's a lot of information and meaning and emotion and so on. All of that is processed by algorithm as data. They use information to get data out of that, and that's how they can process it. And that's yeah. But that's how I would, if I understand it right, also describe your second distinction between algorithm and heuristic, because that's the problem you always have. Because algorithms, they process data and produce some results, which by themselves are not decisions. Also, people say decisions, they're not decisions. They are just processing results and their computations. And the question which is opening or fits with your algorithms is how to use heuristically these results. Dominic knows this very well, because the project we are working on is in precision medicine, and that's how the question is, because the algorithm find all kinds of mutations and results, but the question how you use it, and the question that when people talk about actionability or our ideas how to do, how and can we use it in a sense, and are we using it the right way? So that the problem all fits. Another of our project is with predictive policing, and then the question is even more blatant, because let's assume the algorithm can give you indication about the possible place where crime is going to, or people are going to produce crime. The huge problem of the police, how do you use it? Because of course you cannot put people in jail, but this information not necessary. If the goal of police is reducing crime, uses the information the wrong way can increase crime. So the result of it is no decision, and the question is completely open. But that's the issue dealing with algorithms.
Yeah, I mean, the point I wanted to make with the distinction between heuristics and algorithm is based on determinism. Algorithms are deterministic, and heuristics are not.
And the decisions by themselves are not deterministic, otherwise not a decision. It wouldn't be a decision, it was if we decided at the beginning.
Yeah, please, I would like to point to this last point and ask you, Elena, about the relationship between the production of algorithms in the present and functional differentiation, because there is some risk, as you have mentioned now, in the area of predicting crime, for example. But in every system, it seems to me, or in most of the system, of the social system, it seems to me that the algorithm production of information accelerates functional differentiation. For example, when you speak about the self-fulfilling prophecy, or how you say that, defeating self-defeating circularities you mentioned in your book, I was thinking, yes, this is what algorithm information through algorithm produces, but this is the fundamental way in which the autopoiesis of social system motivates itself. Because when you think about an algorithm that proposes some product to you, some service, and you accept in the economy those service, then you accelerate the production of buying and selling the algorithm makes autopoiesis easier to the economy in some way. And when you have a match, for example, in politics with a candidate, and the algorithm helps the system to produce selectivity also. So maybe in science is in a way different, because science have not to repeat, but the canon in science, the canonical text or the canonical scientific research, the core of one discipline, is always reproduced by repetitions, and does entail the risk of crisis, the risk of too much repetition, and then the collapse of the system because there is no variability in the system, and the system reproduces always the same. But this is the way in which every functional system works. So I mean, maybe there is some risk, but it's also the algorithm production of information is also a way to accelerate functional differentiation. What do you think about that?
Well, I don't know. We should talk about it. I think as always, one should have some concrete examples to see what is that's a fascinating idea. But well, first of all, if I understand it right, by accelerating functional differentiation, you mean accelerating the autopoiesis of the functional systems. I mean,
yeah, or increasing selectivity of
not that the Ausdifferenzierung gets become.
No, not the differentiation of system, but the autopoiesis.
We already have functional differentiation, and we have functional subsystem, and as I understand what you say, and they're working autopoietically, and the reproduction of the operation of the system becomes faster.
Yeah.
Okay.
This is the argument.
Yeah. That's it has some points. But for example, you reported about finance, and people talk about the high frequency trading. That of course it's unbelievably fast, and in other cases you have this kind of acceleration. But can we make a general point? I think political system. I don't think it accelerates. We should talk about this, but the problem of the algorithm produce problems or issues, issues in all the system. And I think that's in the case of political system, the question is rather polarization, which produces a sort of paralysis of the system, not a quick at first sight. I don't know. I will think about it. I don't know. In the case of political system, that seems to me to accelerate the operation of the systems. So one could maybe look from case to case and see in which condition it becomes faster, in the case it's different. The law could be, but they have so many. I don't know. There's Gunnar Thorne is making wonderful work and explaining how it's happening in the law with the algorithms are really, really interesting. And what he observes are cases of legal gaps, a condition where the algorithm, for example, about liability and so on. That's actually even the legal system seems to be okay. You can elaborate the material much quicker because the machine does it, and the lawyer already has the product. But to come to the decision is not necessarily. I don't know. So I think you are right. It's an interesting point, but one should check from system to system to see what's happened in the different cases.
I was just wondering if I should say something about that. But first, I would ask if there are more comments or questions. So if this is not the case, and well, at this moment I just looked at the watch and realized that we are almost at the 2-hour marks now. So I think we can maybe wrap up the conversation for now. And again, thank you, Elena, very, very much for your presence. It was really fascinating conversation, and thank you really a lot for having been here.
I really thank you. It was very much fun and really, really interesting, challenging and interesting. Well, we miss a conversation where we can really go talk with the system theoretical concept, knowing the people know what they're talking about. It happens much too seldom. So it was really a pleasure. Thanks a lot.
Thank you.
Thank you very much.
Thank you, Carlos, also for the invitation.
So
Feliz Navidad a todos. Felices fiestas.
yeah.
Feliz Navidad igual. Merry Christmas.
Merry Christmas.